Okay, let's solve a sample problem here regarding lateral earth pressure. We have a frictionless vertical wall has a height of 4 meters and retains a horizontal surcharge of 10 kilopascal. The unit weight of the backfill is 15 kilonewtons per cubic meter with a cohesion of 8 kilopascal and angle of friction of 26 degrees. Compute the following: the maximum depth of tensile crack, the active force after tensile crack occurs, and then the passive resistance per unit width of the wall. So let's draw first our retaining wall. In our retaining wall, it carries a horizontal backfill with a unit weight of 15 kilonewtons per cubic meter, cohesion of 8 kilopascal, and then angle of friction of 26 degrees. The height of the wall is 4 meters, and also it carries a surcharge equivalent to 10 kilopascal. For the first requirement, that is the depth of tensile crack. Para makuha natin mismo yon, we will assume that the soil is in active condition. So para makuha natin active condition, ano ba yung formula ng ating lateral earth pressure with respect to active condition? That is equivalent to Q plus effective vertical stress multiplied by Ka minus 2C square root of Ka. Okay, wherein Q is the surcharge, effective vertical stress, Ka, the active pressure coefficient of soil, C is cohesion, and then Ka, active pressure coefficient. So, assume muna natin yung point na to. Kunin natin mismo yung effective horizontal stress at this point, or the lateral earth pressure at this point. So, let this be sigma 1 prime. For sigma 1 prime, yung surcharge sa point na yun is 10 kilopascal. Dahil ang surcharge, pare-parehas lang mismo yung effect niya with respect sa depth of our soil. Kahit na lumalalim tayo, yung kinoconsider nating point, parehas lang mismo sa effect mismo dun sa ground surface, which is 10 kilopascal. Plus, effective vertical stress. Sa point na to, wala pa tayong ina-analyze the soil. Wala pang depth. Therefore, effective vertical stress is 0. Compute Ka. Ka is equivalent to, lagay natin dito, 1 minus sine of phi prime over 1 plus sine of phi prime. And that will be equivalent to 1 minus sine of 26 degrees over 1 plus sine of 26 degrees. And Ka therefore will be equivalent to 0.39. So multiplied by 0.39 here minus 2 times the cohesion 8 square root of 0.39. So computing for sigma 1 prime, that will be equivalent to negative 6.09 kilopascal. Nasa negative side. 6.09. So, pag drawing natin yung pressure diagram natin, nandito siya kay negative side. And then, compute naman natin yung ating lateral earth pressure within this depth, 4 meters below the ground surface, and let this be sigma 2 prime. Yung surcharge doon, parehas lang mismo sa ground surface, 10 kilopascal plus effective vertical stress at this depth, ground surface, papunta doon. Wala tayong tubig, therefore, yung effective vertical stress at saka yung total stress ay parehas lang. So, that is equivalent to 15 times 4. Multiplied by the active pressure coefficient, 0.39 minus 2 times yung cohesion sa point na yon, 8 pa din, square root of 0.39. So, computing for sigma 2 prime, that will be equivalent to 17.33 kilopascal, and that is positive. Excuse me. This is 17.33. So, kapag i-connect natin yung dalawang points natin, yan mismo siya, and that will be our pressure diagram, soil pressure diagram. So, yung intersection na to, mula sa ating ground surface, that will be the depth of tensile crack, and that is unknown. Para makuha natin yon, as you can see in the figure, these two triangles are similar. Therefore, we can use ratio and proportion to solve for this depth. And that is by ratio and proportion, 6.09 corresponds to Z, equivalent to 6.09 plus 17.33 corresponds to a height of 4 meters. Computing for the value of Z, that will be equivalent to 1.04 meters. And that will be our first requirement. For the second requirement, compute the active force after tensile crack occurs. Okay. So, tapos nang mag-occur yung tensile crack. After tensile crack occurs, within this depth, wala na, hindi natin i-analyze. Ibig sabihin, nasira na yan, nandito na yung ground surface, ang effective depth of soil na lang ay, eto na lang. So, ibig sabihin, after tensile crack occurs, ang pinapakompute na force ay yung volume ng pressure diagram na to. So, para makompute yun, that is just the area. Area kasi nga, per meter tayo, walang given na length ng ating retaining wall. So, that is the area, 1/2. The base, 17.33. Multiplied by the height, that is 4, minus the depth of tensile crack, 1.04. So, PA, therefore, will be equivalent to 25.61 kilonewton per meter length of our retaining wall. And that will be our second requirements. Third requirement, the passive resistance per unit width of the wall. Ano daw yung passive force natin? Etong mga values na to, hindi na natin siya pwedeng gamitin dahil values siya in active condition. So, i-drawing muna natin ulit yung ating pressure diagram with respect sa passive condition. Dito sa point muna na to, sa ground surface, let this be sigma 1 prime ulit for passive condition. For passive condition, ang ating lateral earth pressure formula is surcharge plus vertical stress effective Kp plus 2C prime. This is square root of Kp. So, compute natin mismo yung earth pressure coefficient natin, Kp. Kp is equivalent to the reciprocal of Ka. That is 1 over 0.39. And that will be equivalent to 2.56. So, substituting now, kunin natin yung effective stress dito, lateral. The surcharge at that point is 10 kilopascal plus, wala pa tayong effective vertical stress doon sa point na yun, multiplied by Kp, 2.56, plus 2 times the cohesion, 8, square root of 2.56. So, sigma 1 prime is equivalent to 51.22 kilopascal. So, positive siya. So, this is 51.22. And then, compute naman natin yung ating lateral earth pressure at a depth of 4 meters. So, let that be sigma 2 prime. Again, the surcharge, walang magbabago doon. Parehas ng effect, 10 plus the vertical stress. That is 15 times 4 multiplied by Kp, 2.56 plus 2 times the cohesion, 8 square root of 2.564 Kp. Computing for sigma 2 prime, that will be equivalent to 204.88 kilopascal. So, positive din. 204.88. Connect natin dalawang point. And that will be our soil pressure distribution. Again, with respect to passive condition. So, para makuha natin yung passive force, we will just get the area of this pressure diagram. So, PP is just the area that is 1/2 the mean base, or 1/2 or mean base times the height. So, that is 1/2 of 51.22 plus 204.88 multiplied by the height, 4 meters. So, the passive force is equivalent to 512.19 kilonewton per meter length of the retaining wall. And these are the requirements for this given problem.